That'll work. So the first thing is, it says if EFGH is a parallelogram. So I'm going to draw a parallelogram. That's why I put a bunch of space for you to do it. Remember, on the test, I do expect you to draw stuff for points. So EFGH. Now what I'm going to do is I'm not even going to look at the questions. I'm just going to say what it means to be a parallelogram and put all that information on it. So first of all, to be a parallelogram, opposite sides need to be parallel. So I'll draw parallel lines on FG and EH. And then I'll draw parallel lines on FE and GH. Then I'm going to note that opposite sides need to be congruent. So I'll make FG congruent to EH. I'll make FE congruent to GH. And finally, we know angles that are across from each other are congruent. So E is congruent to G. F is congruent to H. We also should, there's no real way to mark it, but we should know that consecutive angles are supplementary, so they add to 180. So it'd be something like G and H and E would add to 180, E and F and G would add to 180. So knowing those facts and having this picture should make this problem a lot easier. Because the first thing it says is angle E congruent to angle F. E is not congruent to F, so that can't be right. Is FG parallel to GH? FG is here. GH is here. Those can't be parallel. Is F congruent to H? F is congruent to H. And the last thing says, is E plus G equal 180? E plus G is congruent. It could equal 180, but we don't know necessarily that it's 100% true. So we're going to scribble that out. Through it real quick. So we have to name all these letters. So the first thing we know is we have a parallelogram. So we have a bunch of parallel lines. I should put double tick marks on there. Since we have parallel lines, 56 and V would be alternate interior angles. So V would be 56 degrees. And U and 26 would be alternate interior, so that would be 26 degrees. How do I get to W? How do I get to W, Libby?
What I did, I looked at the 26 on the bottom left corner,
Mm-hmm.
and then I realized the bottom triangle is an isosceles triangle. Right?
Well, we don't know that for sure. Not yet, but we do know. Do you see this triangle? It turned out you were right, that it was isosceles. But we should have started at the one we knew for a fact was isosceles, because you see it's 8 and 8.
Oh, yeah.
Yeah, so 8 and 8 would mean our base angles would be congruent. So W would be congruent to that 56 degrees there. So W would be 56. So that is 56. How do I get to the X and Y then? How do I get to the X and Y then? Well, you all got it right, so Sana?
Oh, so X I got. You want me to explain how I got or from there?
How do I go from here to get to X or Y?
So you vertical angle of W is 56.
So that's my vertical angle, that's 56.
And X have to equal 180 minus 112.
Mm-hmm.
So it's 68.
It's 68, cool. All right, you can stop there, because unless I'm going to do Y then.
Okay.
How do I get Y? EJ?
Well, like linear pair from 1 to 56s makes the equal 124. Yeah, that one. And then you add 124 plus 26, and then you subtract that number from 180.
Mm-hmm. And what does that leave me with for Y?
30.
30 degrees. So EJ recognized that we had a linear pair here to give me 124. Well, we already had that 26. 26 plus 124 is 150. 180 minus 150 is 30. Did you have another way?
Yeah, so using the same side interior,
Mm-hmm.
56 plus 26 is 82, and then 180 minus 82 is 98, so then 98 minus 68 would be 30.
Yeah. So she was saying this angle here in its entirety is 82, which means this entire angle must be 98. This angle right here has to be 98 degrees because same side interior or consecutive angles of a parallelogram. So then you just do 98 minus 68, which equals 30 degrees. Is it okay? There's two ways to do something? Yeah, as long as you're doing things correctly and you're not making up your own rules. All right, questions on the bell work? Questions on the homework? Before we do questions on the homework, I do want to go over 20 really quick because several of you missed it in the answer guide. And it is important. Because up until now, we did kind of these factoring problems. And as soon as I came up with a negative, I erased it and said that can't work. But in this case, the negative 5 does work for y. Because if I plug negative 5 in for y squared, it comes out to 25. Negative 5 plus 30 is a positive 25. Is there anything broken with the negative 5?
No.
Nope. So negative 5 is an answer to it. That's why I have y equals 6 or negative 5. All right, that being said, what questions do we have from the homework? EJ? 22. So 22 is probably the most challenging elimination problem we've had so far. Now the first thing we need to recognize is we have a parallelogram, which means alternate interior angles are going to be congruent. So this 9y is going to be congruent with that. And then you should have came up with this 3x is congruent to that, right? Which comes up with these two equations. 4x plus 1 equals 9y. 7y minus 2 equals 3x. And I make sure everything is on the same side. So you should have had the 4x minus 9y equals negative 1 and negative 3x plus 7y equals 2, correct?
Yeah.
Okay. Now to eliminate, we need to have a zero pair, which means I need to have a pair that cancels each other out. What I looked at is this 4x and this negative 3x. And why I'm looking at both of those is because they're already opposite. They're already opposite. Now they just have to be the same value opposite. So in order for those to be the same value, I want to multiply the 4 by 3. I'll multiply the negative 3 by 4. But that means I need to multiply the entire top by 3, which comes out to 12x minus 27y equals negative 3. And I need to multiply the entire bottom one by 4, which gave me negative 12x plus 28y equals 8. And these cancel out. I'm left with y equals 5. And then you plug the 5 back into another equation, and then you should come up with x equals 11.
Yeah. Okay.
Do you have a specific question, or?
No. Nothing good.
You sure?
Yeah.
Probably just a little mistake somewhere.
Mm-hmm.
Okay, cool. Yeah.
Can I know that one?
Yeah. Labib.
Number 3.
Number 3.
I said that it was theorem 7, but on execution, no.
Well, what does theorem 5.7 say? Can you read it to me?
Yeah, if the diagonals of a quadrilateral bisect each other, then the quadrilateral is a parallelogram.
Mm-hmm. But it has to be both sets of diagonals, right? Do you see how this is just one of them? Labib, you would have been 100% correct if I would have a marks right here. Then it'd be both sets of diagonals bisect each other. But since that's missing, all we know is this one bisects this one, but we don't know that this one bisects the other one. So you need both pairs being congruent. Okay? Yeah.
For 25,
Mm-hmm.
I did it like you said.
Yes, you probably did it right. So you proved it as a parallelogram, and then you said opposite sides are congruent? Yep.
Do you have to write the segment SR equals segment PQ?
No.
Or do you just,
Nope. You could just say that the segment you're looking at, right, SK and KR, like we did in the homework, just break it apart.
yeah.
Yep. That'd be fine. Krupa.
After you prove this parallelogram, can you just say that SJ equals QK because of the definition of parallelogram?
Not the definition of parallelogram. Theorem 5.1 says it. Theorem 5.1 says opposite sides. The definition of parallelogram only says it's a quadrilateral and that the pairs are parallel. So that's the only thing you can pull from the definition. Anything else has to be a theorem. So opposite angles being congruent, opposite sides being congruent, all of those have to be a theorem. Does that make sense? Cool. Yeah, it would be.
For number 23 and 24,
Mm-hmm.
is the equation always known
Be careful because it could be a different theorem. It could be a theorem that says, it's a rectangle. Prove it's a rectangle. We'll get to other theorems that are like prove it's a rectangle. So that prove would be prove that ABCD is a rectangle.
Okay, so how do you know that, which,
It'll always be that statement that comes after then.
okay.
That's why in your notes I had you circle the if statement. That is your given. Anything after the then is what you need to prove. So basically, read then, and then you can pretty much write down what it says after that, and that's what you need to prove. Okay, so it might say if this, then it's not parallel, or then it is a rhombus, then it is a triangle. It'll be whatever's after that, then what is your proof statement.
Okay.
Is that
Yeah.
good? All right. Because I know those can be confusing because they're kind of weird because you're setting up the given
Yeah.
and the proof, and you're like, how do I do that? Yeah. Other questions? Krupa, you're just playing with your hair, right? Okay. No, that's okay. You just like pause at the stage where it might be I'm asking a question, but I don't know what I want to do. All right, if there's no other questions, we're going to get into some new theorems today. So we're getting away from parallelograms, and we're getting into just parallel lines. This can seem confusing at first. So let's read it. Remember, you can put notes on your sheet. So it says, if 3 or more parallel lines cut off congruent segments on one transversal, then they cut off congruent segments on every transversal. Yes?
Are we starting with this or this?
Did I skip one on my notes?
No, maybe.
Did I just not take a picture of it? There we go. Yeah, I'd have been okay if I skipped this one. We don't use this one very much. That's probably why I didn't put it. So it says if 2 lines are parallel, then all points on one line are equidistant from the other line. So if you have 2 parallel lines, that means the distance between them is always the same. It will never get closer, right? Because they're completely parallel. They're always the same distance away. So that's what this is saying. That 2 parallel lines are always the same distance away. No matter how far we look down this line, they'll always be the same distance away. So that one isn't exactly earth-shattering. We don't use it very often either. But it builds us up to 5-9. 5-9 says if 3 or more parallel lines cut off congruent segments on one transversal, then they cut off congruent segments on every transversal. This is just kind of like an offshoot of 5-8. Parallel lines never get closer or further away from each other. Once we know the distance between them, they're always going to be that same distance. So what this is saying, we have 3 parallel lines, right? We have 3 parallel lines. Now we're going to have a statement that says if. If we know that EF is congruent to FG. So we're going to call this transversal 1. This is my transversal 1, this is my transversal 2. So just looking at my transversal 1, if we can say that this distance is the same as that distance, then we can say that AB is congruent to BC. And it's because that distance is now fixed. You are basically saying the distance from these 2 lines is the same distance as these 2 lines. So that means any transversal you draw, the distances are going to be congruent. So once again, AB would be congruent to BC. If you happen to draw another transversal, so if I draw, oh, that's a bit extreme. Let's draw purple. Let's say I draw another transversal like this. If I draw that transversal, that means that this segment would be congruent to that segment. All right, so if we have 3 or more parallel lines, and we have one transversal that shows that the distances are equal, it'll be the same distance, or all distances using transversals will always be the same. So you create a whole bunch of congruent segments. Now be careful here. Is AB the same length as EF? No. All we know is that AB is congruent to BC. All we know is this distance is congruent to that distance, and that's based upon EF being congruent to FG. Questions on that, because that can be slightly confusing. So basically, 3 parallel lines. One transversal having congruent segment locks it in. That every other transversal you draw will have congruent segments. All right, so 3 parallel lines, 2 congruent segments, locks it in. Are we okay with that? Yeah, Krupa.
What if one of the lines was farther away than the other?
Then it wouldn't work. Because Krupa, we said that this first thing has to be true. So if I had, maybe, correct me if I'm wrong, but you're saying basically I have 3 parallel lines that look maybe something like that? All right, so now this transversal. In order for the other transversal to have congruent segments, this would have to be congruent to that. What would that? That would be a given. Yeah. So even though I drew it weird, if I'd put those 2 congruent signs on, that means that distance is now fixed to be the same, even though it looks different. But if they don't give you that information, you know nothing about how far apart they are. All right. Yes, you will be given that 2 segments are congruent. Other questions? Okay. Theorem 510. Theorem 510. First of all, we're going to use Theorem 5.9 for just a second. We're going to draw another line that's almost the same distance here. Kind of like that. All right. Then what we're going to do is we're going to draw a line down it. Maybe we'll call this a B. Maybe I'll call this M here. Right smack dab in there. Then what I'm going to say is that AM and MB are parallel, are congruent. I was just thinking, I need to make all 3 of these lines parallel, so we'll put parallel symbols on there as well. Yeah?
But it doesn't work, it doesn't work like the opposite way, like there's no converse where like if those 2 parts are equal, then those aren't necessarily.
No, it couldn't. No, you are correct.
Okay.
You are correct. There is no converse. There is a converse if we have triangles, and you'll see that in a second. But just because these are equal, one of these could have been slanted down, right?
Yeah.
It wouldn't necessarily make them parallel. But we're going to build up to a triangle here. So currently we have 3 parallel lines, and these 2 things are congruent. That means any transversal I draw will have congruent segments on it, right? So based upon that, what I'm going to do is I'm going to complete this as a, let's complete this as a triangle. That's another transversal. So we'll call this C. And we'll call this N. Well, since AM is congruent to MB, and the 3 lines are parallel, what do we know about BN and NC then? Yeah.
They're congruent.
They're congruent. Then BN is congruent to NC. So we could put 2 little tick marks on there. Well, real quick, M's a midpoint, right? Because it cuts it right in half. N's a midpoint as well. That leads us to Theorem 510. Theorem 510 says a line that contains a midpoint of one side of a triangle and is parallel to another side passes through the midpoint on the third side. So let's break that down. So let's look at this. All right. So it's saying if MN is parallel to BC, we need them to be parallel lines. We need two parallel lines. If MN is parallel to BC and MN goes through one midpoint, it is forced to go through both midpoints. So if a parallel line on a triangle goes through one midpoint, it also must go through the other midpoint. So parallel lines on a triangle have to either go through both midpoints or no midpoints. All right? It's all or nothing. A parallel line either goes through both midpoints or no midpoints. Krupa.
Would we be given that M is the midpoint?
We would be given something like M is a midpoint, or we can figure out that M is a midpoint. We'd also be given that they're parallel. If we're not given they're parallel, then we're kind of out of luck, if you will. So we know this is parallel because 120 and 60 are same side interior. So we know it's parallel because these are same side interior. Since those are same side interior, we know these are parallel. I don't have to just take it on faith that they're parallel. I can prove that those are parallel. Now we can prove that M is a midpoint, right? So M is a midpoint because this is 6 and 6. So M must be a midpoint. Basically, we can prove that MN is parallel to BC and M is a midpoint. So if M is a midpoint and they're parallel lines, what does that mean about N? Yeah, it's also a midpoint. So MN is parallel to BC and M is a midpoint, thus N is a midpoint. And if N is a midpoint, what's the distance from A to N? Not 6. Jacob?
7.
It's going to be 7. Since N is a midpoint, that means that NC is congruent to AN, which means AN is 7, which means A to C is going to be 14. Yes?
How did you decide it?
I got 7 because, do you agree? So MN is parallel to BC, right? And we said M is a midpoint. So that automatically makes N a midpoint as well, right? So if N's a midpoint, this distance here must be congruent to that distance here. They gave me 7. Doesn't your 7 have there on there? Yeah. Oh, you're writing on the other sheet. I got you. No. They gave me 7, so I knew the other one is 7. I didn't just make up values. That's a good question to have. Does that make sense then? All right, good. I'm going to say that one more time. Parallel lines going through a triangle either go through both midpoints or no midpoints. All right, that leads us to our last theorem. Our last theorem says the segment that joins the midpoints. I forgot who asked about the converse. You asked about the converse. This one does have a converse. So this one says if it goes through both midpoints, then it has to be parallel. So if you find a segment that goes through both midpoints of a triangle, then it is parallel to the other side. And on top of that, it is exactly half the length of that bottom side. It is exactly half that length of that bottom side. Let's do an example off to the side here. Let's draw this. All right, so I have triangle. Let's call it A, B, C. Now we're going to draw a line right there. And I'm going to put little marks showing that those are midpoints. So that line I just drew went through two midpoints of a triangle. That means two important facts. One, both of these lines must be parallel. So that has to be parallel to that. That's what the rule says. If it goes through two midpoints, you're going to have two parallel lines. And on top of that, let's say that this is length 6. What is the length of the base then? Krupa?
12.
It'd be 12. Yep. One more time. Any segment that goes through two midpoints of a triangle is parallel to that other side and is half the distance as that other side. Okay? Yeah, Jacob.
Will that other distance always be the hypotenuse?
It only has a hypotenuse if it's a right triangle. So this isn't a right triangle, so that's not a hypotenuse. Hypotenuse is only if it has a right triangle.
Would it always be the longest side?
It will not always be the longest side, because let's go. All right, let's do this. As long as I put dashes here and here, I have two midpoints, which now means that this line is now parallel to that line. And if I made this 8, that would make this 16. So it doesn't matter. It's just two midpoints. If it's connecting two midpoints, it's parallel, and it's half the distance of that side. That's the opposite of it. Okay?
Yep.
Other questions? All right, so these two are pretty closely related. This one says parallel lines go through both or none of the midpoints. The next one says if a segment goes through both midpoints, it is parallel and half the distance. Okay? Which on this one, I could say that if BC was 10, MN would be 5, based upon that other theorem. All right. Let's put that in action. So it says PQR are midpoints of the sides of a triangle DEF. What is the length of PQ? So just remember, PQ is right here. And all of those are midpoints. So that's a midpoint. That's a midpoint. That's a midpoint. So does PQ go through two midpoints? Yes, it does. So what is the length of PQ? Jacob?
4.
It is 4. It is 4. Because if we look at down here, since it goes through midpoints, it is going to be parallel to that purple side right there. And on top of the fact that it's parallel, it is half this distance. This distance is 8, so that is going to be 4. All right, what is the distance of RQ? RQ is right here. It says that R and Q are midpoints, so we do know that it goes through two midpoints. So that means it is parallel to this line opposite. And what is its length then? Emma? It would be 6. It'd be half of 12. What kind of figure is DPQR? DPQR. DJ? How do we know it's a parallelogram, though?
Well, okay, so PQ is half of DF, so then, and if R is a midpoint, then DR equals R half, so then we take half of
So
that.
DR would be what size?
4.
4? And what would DP be?
6.
6. Does that automatically make it a parallelogram?
Yes.
Do we have a theorem that says opposite sides, if they're congruent, it is a parallelogram?
Yeah.
I'm not saying it's, what theorem is it? Yeah. 5-1. I don't think 5-1, that one says if I have a parallelogram, then opposite sides are congruent. I'm looking for one that says if opposite sides are congruent, then I have a parallelogram.
5-4.
5-4. Do we all agree that should be 5-1 then? 5-4 would prove that. Okay. What is the perimeter? Well, we already pretty much said it's going to be 20 because we said the whole side length. All right, really quick. We really just did 3 important ones. I'm not too concerned about this one. That's just saying two parallel lines never get closer or further apart. This one says if I have 3 or more parallel lines and I have one transversal with congruent segments, any transversal I draw will also have congruent segments. So just like Krupa said, they would give me this fact that they're congruent. Our next one says, hey, if I have a parallel line attached to my triangle, either it goes through both my midpoints or it goes through 0 midpoints. So that means if I have parallel lines and it goes through one midpoint, it automatically goes through the other midpoint. And then the last theorem we talked about is if at any time I have a line going through 2 midpoints, it is parallel and it's half the distance to that third side. Okay? All right. Any questions for me? Dave, you have any questions? No? You sure? Yeah.
For the examples for the what kind of figure is it?
Yep.
So why exactly is it a parallelogram?
We actually have 2 reasons why it's a parallelogram. I didn't talk about the other reason, but the first reason is because what EJ said is R is a midpoint, right?
Yeah.
So this
Okay.
distance must be 4.
Okay.
And we said opposite sides must be congruent. You know what else we could have done? Everyone pay attention to this really quick. There's another way I can prove this is a parallelogram without numbers. If a line goes through a midpoint, like P and Q, that means it's automatically parallel to this side. So we could have said that PQ is parallel to this line, and we could also say that DP is parallel to RQ for the same reason. 2 sets of parallel lines, that's another way we could prove it's a parallelogram, because by definition, it's a parallelogram. So I could actually go 2 ways and prove it's a parallelogram. Okay? Yeah, Labib. Yeah. Any other questions besides do I need to go to the bathroom? Okay, then the rest of the time is for you to work and ask questions. Ask questions, ask questions.